Hey, Zach. All right, so if you, like I said, I'll just bring it up real quick. Your practice for today, it says predict whether or not the reactions are going to happen and then balance them. You work on separate sheet of paper and submit a picture. Still want to do your work on separate sheet of paper and submit a picture. Do your best. Do your best. Yeah, yeah. I mean, don't. I'm not saying hurt yourself. Just do what you can do. Don't do what you can't do.
Like,
yes, no stress. Okay. But instead, what I'm going to do is go through these 10, and I'm going to tell you whether or not they're going to happen, and I'm going to give you their products, and then we'll work together balancing them and classifying them. So I need to be able to see them. That's why I'm moving them over here. And I need a activity series. All right, so let's look at what we have for the first one. We got sodium plus iron bromide. And then what does that equal? All right, so first off, you can kind of tell the reaction that this is going to be already. You got something by itself, and then you have two things. What type of reaction is that going to be? Very good. So this is going to be a single replacement reaction. Already nailed that. Now, how will we figure out whether or not a single replacement reaction works? I'm just kind of giving you this information for future chemistry that you might one day do, because I'm not going to ask you it on the test. But there's a little chart right beside the polyatomic ion chart called the activity series. The higher something is in that chart, the more it wants to be in a bond. So what I do is I compare sodium in this chart to iron in this chart, and I see, is sodium higher? If sodium is higher, it's going to take its place. If sodium is lower, nothing's going to happen. It's going to be no reaction. So pretty straightforward there. Sodium is higher in the chart. Iron is kind of in the middle, and sodium is up a little bit higher. So sodium's going to hook up with bromine.
What is an SR4?
It's a single replacement. It's telling you what type of reaction it is. So sodium's going to hook up with bromine. Sodium has a +1 charge. Bromine has a -1 charge. So it's just straight up NADR. And then iron goes off by itself. Okay, so the only thing left for me to do is yeah. Okay. So now, how many sodiums? Feel good? But there, irons. Feel good? Ashley, bromines? Fix it? Okay. So now I think she screwed you up, didn't she? How many sodiums? Fix it? How many here? And how many here? So I want 3 where? And that's it. I know I do it fast, guys, but you got to tell me to pump the brakes. If I do anything you don't understand, you got to holler at me. I'm gonna write down the next one while you're thinking whether or not you want to question me. Question on top of them? Okay, this one right here. Something's by itself and you got a couple. Once again,
It's single replacement.
Also a single replacement. Okay. Iron's going to come in and try to replace hydrogen. I look on my chart. Iron is above hydrogen, so this will happen. Okay. Mr. Salibi did not tell us what the charge on iron was in this practice, so you can kind of make up whatever charge you want it to be.
2.
Sure, we'll say it's 2. So we'll say this is an iron 2. Sure. I just sort of throwing out and make sure I understand, because it matters, because hooking up with bromine, we need a charge. And if it's an iron 2, bromine 1, you got iron bromide. And then hydrogen is kind of special because most of the time when something goes off by itself, it's just by itself. The hydrogen's a gas. It never exists just by itself. So instead of just H, what am I going to put?
E2.
H2. Excellent. All right, Mr. Styron. Hydrogens?
You're gonna put 2 in front of the H.
Anything else?
Don't you go?
Anything else?
No.
That's it. 2 H's, 2 H's, 2 bromines, 2 bromines, 1 Fe, 1 Fe.
Was that plus 2 for above that?
Just to, because you needed a charge for the iron, but I can get rid of it now. Because you're not gonna have to do that on Friday. Rocking and rolling?
It's easy when it's explained.
It's easy when we're talking it together.
Yeah.
And that's why when we talk it, that's why I like to talk it a bunch together to get that dialogue in your head. Like get that rhythm in your head. Because to me, this is kind of like a rhythm thing. It's like, how many sodiums? 1 sodium there, 3 sodiums there. I need a 3 there. You just kind of get the rhythm of going and you keep on rolling. It's kind of like figuring out how to do math. Okay. All right, I'm gonna go to a new slide to give myself some room. All right, we got some silver. What's copper sulfate? Yep. Okay. I'm going to compare once again single replacement. You guys are nailing it. Single replacement. Actually, just about all of these are going to be single replacement all the way down, just because that's how we can use this. So just about all of these on this practice are single replacement. I'm going to see, is Ag higher than copper? Ag is near the very bottom. Copper is just above it. This. Yep. What does that mean?
No result. No replacement.
No replacement, no results, no reaction.
Okay.
And now you sure that would be fine. This just isn't going to happen, and you're done.
Impossible.
It doesn't happen because silver doesn't replace copper. Once again, I'm not going to have a question like this on the test because I just don't feel like it's important enough. I really want you to get balancing and classifying down. Just no reaction, you're done. All right, next one. Potassium plus iron nitrate. Nitrate. Once again, it's a replacement. You got one thing by itself. Look at potassium. Potassium is very active. It's near the top. So anything in group 1 is going to be very, very active. It really wants to bond. So potassium is very active. Iron is not very active. It's near the middle. So it is going to happen. So you end up with K. NO3 has a -1 charge, so it's just KNO3. And then iron goes off by itself. All right, Martin? How many Ks?
There's 1 there.
How many over there?
There 3.
Where's the 3 that goes to the K?
Oh no, the 3 goes to NO.
The 3 goes to
Or
just the O.
Okay, yeah. So it's
Okay.
1.
1 and 1. Josh, Fe?
1. No, there's 2. Wait, never mind.
1 and 1.
Yeah.
Matthew? N's?
3.
Okay, that you just said that 3 is only going
For O's.
to the O.
1.
There's 1, but then you got a parentheses. So how many?
2.
Because what this means right here, that right there, what it means is that. You understand? Cool? All right, so we have 2 N's. How many here?
1.
Rock and roll. How do I make them 1 or 2?
Put parentheses.
Can't put parentheses because that changes what we have. The only thing that we do when we balance is put big numbers in front.
Put 2.
There you go. Who did we screw up? Did it screw up you more times? Okay, how many Ks?
There's 1 on that side, 2 on the other, so you just put the other 2 in front of the other.
And did we screw you up, Josh?
No, you were FE.
That's it?
No, that's it.
Kick it down like fast? All right, let's go. We are one more to be halfway. Or no, wait, that might have been halfway. No, it's not. One more to be halfway. All right, so we got some iron. Hook it up with some manganese bromide.
It's gonna be a single.
And let's say this iron's +2 as well. All of these are single replacement. I'll let you know when they're not. Yeah, all of these are single replacement. Iron with manganese bromide. Once again, the iron jumps in. Is the iron higher than manganese? No, it is not. I like it when they don't have to do it. The iron's not higher than the manganese. Don't worry about it, and we're rolling on. So, like I said, I'm not going to ask you to do a test. Do it on the test, but pretty straightforward stuff. Number 6 is just like number 2. So, whatever you did on number 2, do it for number 6. We'll roll on. Let's do number 7. Zinc. If I could write things correctly. Whoops. What I do? All the way down the page. Zinc. Hook it up with some carbonic acid. Don't worry about naming acids right now, but something to stick with me. All right, zinc's higher than hydrogen, so this is going to happen. Zinc also always has a +1 charge. Don't worry about that, but it'll be pretty easy one to balance. 1 zinc, 2 zincs. 2 hydrogens, 2 hydrogens, 1 carbon, 1 carbon, 3 oxygens, 3 oxygens. I like it when they're fun. All right. I'm gonna skip the next one because it's almost the same thing too. So I'm skipping the next one too. Let you do number 8, kind of similar. And look at number 9 and 10 are both different types of reactions. So we get off the single replacement.
This is not.
Yep. I might have to make myself some green.
This is a double replacement.
Very good. Because you got 2 things adding to 2 things. They're going to change partners. And you use solubility rules to see if it's going to happen.
No.
Bromides. Where does it say bromides? Bromides accept silver and mercury, so that'll be soluble. And phosphates. They don't even say phosphates down here. Mr. Saliba, what you doing? There it is right there. Phosphates except group 1. It is a group 1 phosphate, so it'll be soluble as well. So this actually won't happen, but I'm gonna do it anyway because it's good practice.
If it won't happen, why are you doing it then?
Because it's good practice. I literally just said that. Come on, man. All right, so sodium hooks up with the phosphate. Phosphate's got a 3 charge, so it'll be Na3PO4. And potassium hooks up with the bromide. Potassium +1, bromine -1, KBr. All right. Let's go back and front. Martin, sodium.
There's one on that side, 3 on that side.
Fix it.
Put it 3 on the other.
Rock and roll. Ashley, bromine. That's a. Tanila, potassium. Rock and roll. Josh, phosphorus.
There is 1, and there is 1.
Rock and roll. With Derek, oxygen. Everybody happy? And then the last one, silver nitrate and sodium carbonate. Just leave maybe things too easy. That's an easy one too. One silver, two silvers. How many nitrogens?
There's 3 over there. I'm gonna
Nope.
find
2 nitrogens,
Oh.
1 nitrogen. I mean, save oxygen for last because it's in 2 places. Everybody with me there? See oxygen's in 2 places, so we save it for last.
You just screwed up
Okay.
an A. Could you put
How many
two over
NAs?
there? There's only, there's 2 over there, you didn't screw it up, you made it even.
Count. Okay.
You know what, Daniel?
1 carbon, 1 carbon. Now we check our oxygen. Here we go. Oxygen's just right here. 6. Everybody cool? Plus
3,
total of
9, 3,
plus
6,
9. Looks happy to me. 2 silvers, 2 silvers, 2 nitrogens, 2 nitrogens. Rock and roll. All I can tell you to do is practice, guys. That's why I didn't do the practice from the previous 2 days on this. I want you to spend time practicing, okay? Because, yeah, I agree with what Josh said earlier. When we're working this together, it's easy breezy. But when you're by yourself, you got to really take a breath, okay? So today's practice should be pretty straightforward because we did all but 2 of the problems right here together, okay? And 2 of the problems just match up with other ones. That's why I didn't repeat it. And so yesterday's practice and last Friday's practice, jump on. If you need help, here I am. And we got this test on Friday. Tomorrow we'll practice and answer any questions. Test on Friday.
No.
What do you say, Ashley? I'll be honest with you. If you're in class and you show it to me, I'll give you credit. If you're at home, submit the picture, yeah. If you want to submit a picture in class, don't want to talk to me, that's fine. You can do that too. Okay? Everybody cool?
Honestly, I've been wasting my breath the whole time.
I don't believe that you would be quiet if I wanted to do more.
You were right.
All right. Cool. I got some in the chat. Hold up. Hello, Zach. Do some work, buddy.
No, go away, Zach. Good boy.